Today we're going to do a quick introduction to trigonometry. Trigonometry is the study of the properties of triangles. In this particular case, you will need a scientific calculator that can do sine, cosine, and tangents. We will be looking at a right triangle, and with this right triangle we do see a right angle. We also see another angle. In this particular case, that angle is labeled x degrees. This angle will be known as a reference angle. We do know opposite of the 90-degree angle is our hypotenuse. We learned that when we worked with Pythagorean theorem. And using our reference angle, we can find the other two sides. Opposite of our reference angle will be known as our opposite side, which leaves the last side to be our adjacent side. The word adjacent means next to, and this is the side that is next to our reference angle. There are three trigonometry functions that we will be memorizing, and that is the sine of x degrees is equal to the opposite side divided by the hypotenuse. The cosine of x degrees is our adjacent side divided by our hypotenuse. And the last rule is the tangent of x degrees is our opposite side divided by the adjacent side. To help us remember these rules, we use the saying called so, ka, toa. So is S-O-H, ka is C-A-H, and toa is T-O-A. The S stands for the sine of x degrees is equal to O for opposite over H, our hypotenuse. So S is our sine, O is our opposite, H is our hypotenuse. The same thing goes for the other two rules. C standing for cosine, A stands for adjacent, H stands for hypotenuse. In TOA, T stands for tangent, O stands for opposite, and A stands for adjacent. We're going to be using these three rules to help us find our missing side. In this particular right triangle, we do see that we do have the side 21. This side we do not know, and that's the side that we will be looking for, so we'll go ahead and just label that X. And this side we don't have anything, so we just don't need it. We cannot use Pythagorean theorem because Pythagorean theorem requires to have at least two sides. In this particular case, we're only given one side. So we do know that we have to do trigonometry. In order to do so, we'll follow four simple steps, and our first step is to identify what our sides are. We do know that opposite of our right angle will be known as our hypotenuse. So in this particular case, the hypotenuse is 21. We see that we have a reference angle, which is 36 degrees, and opposite of our reference angle will be known as our opposite side, which leaves the third side to be our adjacent side. With that information, we can now determine which rule to use. We'll go ahead and use that saying SOHCAHTOA to help us find that out. In this particular case, we can see that we do have a hypotenuse, which is 21, and we are searching for this side, which is x. The adjacent is not needed since there is nothing labeled. So we'll just go ahead and cross that out. So looking at our rules, we're going to look for something that has the opposite and the hypotenuse. And we can see that sine, or our SO, is the only one that has both the opposite and the hypotenuse. The others are missing one or the other. In cosine, we're missing the O. They give us the A, but not the O. In tangent, we're missing the H. They gave us the A, but again, we're missing the H. So in this particular case, we do know that the only rule that we can use is SO. For SO, the letter S stands for the sine of x degrees is equal to our opposite over our hypotenuse. Now that we know which rule that we're using, we could go ahead and substitute our known variables. So I'm just going to go ahead and find out the sine of x degrees, and x degrees is our reference angle, which is 36 degrees. We see that right over here. And that's equal to our opposite, which we do not know. So I'm just going to label that as x. And our hypotenuse is 21. Using our scientific calculators, I'll go ahead and find out what is the sine of 36 degrees. Now, depending on your calculator, you may need to hit the sine button first, then 36, and enter. Other calculators, you might need to hit the 36 first, and then hit sine. Also, be sure to have your calculators in the degree mode, otherwise you might get a different answer. The sine of 36 degrees happens to be 0.5878, and we always round it to our nearest 10,000th place, which means 4 placeholders. We'll just go ahead and bring down our x over 21, and now we can just go ahead and solve for x algebraically. Since we have x divided by 21, to get rid of our denominator, we multiply by whatever that denominator is, and that denominator happens to be 21. And what we do on one side, we do to the other. That way the two 21s will cancel out, and we're left with x. On the other side, we can go ahead and do 21 times 0.5878, and we end up with 12.3. So we have 12.3 is equal to x, but as usual, we do need to go ahead and rewrite it so that it says x is equal to 12.3. And again, check the problem to figure out what label that we've been using, and we have been using the label feet, so we have 12.3 feet. So our final answer is x is equal to 12.3 feet. That last step that we did was just solving for the missing variable. We're going to go ahead and do one more example, which is slightly different, yet we'll go ahead and continue to follow the same 4 steps. In this particular case, you will have a problem that gives you one of the sides, and in this case we do have 10 meters. We have a reference angle of 32 degrees, and then we're missing the side x. Before beginning, we should always write out the saying so, ka, toa. This helps us figure out which rule that we're going to be using. The first step that we needed to do is to go ahead and figure out what are our sides. We do know opposite of the right angle is our hypotenuse, and opposite of our reference angle will be known as our opposite side, which leaves the third side being our adjacent. Now we need to determine which rule that we're going to use, and we can see that we have the adjacent side and we're searching for the hypotenuse. So the side that we do not need is our opposite. So of the 3 rules, the only thing that contains both the adjacent and the hypotenuse is the ka, C-A-H. The C stands for the cosine, so the cosine of x degrees is equal to A, which is the adjacent, over H, which is our hypotenuse. The third step is to go ahead and substitute our known variables, and we do know that the reference angle happens to be 32 degrees. We see that right over here. We put in our equal sign. The adjacent is 10. And the hypotenuse, we do not know. So we'll go ahead and label that as x. Again, using our scientific calculators, we could go ahead and type in the cosine of 32 degrees. And if we go ahead and type in the cosine of 32 degrees, we get 0.8480 if we round it to the nearest 10,000th place. We'll just bring down the equal sign and the 10 over x. Now in this particular case, the x is in our denominator. So again, in order to get rid of our denominator, we need to multiply by whatever that denominator might be. In this case, it happens to be x. And what we do on one side, we go ahead and do to the other. What happens here is that both of these x's will cancel out and we're left with our 10. However, on the other side, I cannot do x times 0.8480. So all I'm going to do is just rearrange them so that I have my number first, 0.8480, and the x right next to it. So now I have 0.8480x is equal to 10. Again, I do want to get x by itself, so I need to somehow get rid of that 0.8480. In order to do that, I'm just going to go ahead and divide by 0.8480 because 0.8480x just means to multiply 0.8480 with x. And in order to get rid of it, we'll just do the opposite, which is divide. These two 0.8480s will eventually cancel each other out, and we're left with x. Now I just need to do 10 divided by 0.8480. And if I go ahead and do that, that will give us 11.8 meters. And I do know it's meters because if I take a look at my problem, I see that little m. So our final answer is x is equal to 11.8 meters.